Germany in the year 2019. Black Friday isn't a thing here. Well, at least it wasn't until now. It took only a few years of marketing to gain a permanent foothold anyway. This tells me that we have become a mindless consumer culture that has all but forgotten about its roots. But behind the shiny facade of this ignorant and frankly wussified society is a dark abyss filled with mountains of things that had to go before their time. And then there are people like us who will descend into that forbidden realm to retrieve the treasures of yesterday so that maybe there still remains a chance that there will be a tomorrow. So follow me along on another treasure hunt through the scrapyards, looking for great parts and tools to retrieve, repair and repurpose. Here we have a pile of steel that looks like it just came from the steel mill, and I often take stock material home for the scrap price. These pieces here are a little too short though for what I have in mind. And what is this? Two old German tape recorders, a Telefunken and a Dual. Unfortunately, they have become very wet here at the scrapyard and the wood casings are damaged beyond repair, I'm afraid. I also already have a number of these. This odd looking cast iron object here though, I will take home. Here is a small air conditioning unit that doesn't even look that old. I built a silent air compressor with a similar unit in a past episode, but at the moment I have no use for this. I had almost missed this, but look at that, between the scrap I have spotted a very rare car radio. This is a keeper. Let's hope it's not gotten too wet. Since a lot of cars are stripped here, you can find, well, a lot of car parts. These battery cables could be useful for welding or solar applications, for example. This machine here seems to be a kind of lift for patients at hospitals. I'm sure that this is pretty expensive equipment, but unfortunately it has been seriously damaged, probably here at the scrapyard. And what do we have here? A big DC motor, probably from a treadmill. Hard to find in these parts, but we could do awesome stuff with this. Let's take it home. Well, back to the shop then. So remember this cast iron object here? Some of you have probably already guessed that it is a kind of flat iron. As it turns out, this is a special kind of laundry iron that was coal powered. Coal was placed inside the iron and this little chimney was used in order to allow oxygen flow to the smoldering coal inside. To fix broken cast iron is very hard and it will never be restored to its original state once it is broken. You can weld cast iron, and I have done that a couple of times before with welding electrodes containing nickel. But this time I want to try to braze the cast iron, in German hartlöten, meaning hard soldering. Now brazing, like soldering, works at temperatures lower than the melting point of the workpiece, which differentiates it from welding, where the temperatures are high enough to melt the workpiece itself. When soldering or brazing, you use a solder wire or filler material that melts below the solidus temperature of the workpiece, with soldering being under and brazing over 450 degrees Celsius. In order to braze the cast iron, I need something way more powerful than my little propane torch though. I need an oxyacetylene torch, in German Autogenschweißgerät. I wanted to have an oxyacetylene or oxy-fuel torch for years, but could never afford it. Recently I got my hands on this old cart or dolly here, and I took this as an opportunity to finally get an oxy-fuel torch. With it came an at least half-full 20-liter acetylene cylinder. The oxygen cylinder I had to buy as a new part. A new cylinder plus 20 liters of oxygen costs you almost 200 euros. That's why I thought it was a good idea to get a used torch that still made a good impression. So I bought this one here. It was made by CIS MMW in 1980 in what was then socialist East Germany. So today my greetings go out to the viewers in East Germany and especially in Saxony. But I quickly realized that I was a fool for buying a used oxy-fuel torch because this is a really dangerous tool. This video documents how I got it running after all, but I want to make clear that I do absolutely not recommend to buy used parts for a tool this dangerous. So here are the various issues I have to fix before we can repair the old laundry iron. Though these old pieces and nozzles still look pretty good, the old rubber O-rings have dry rot and need to be replaced. The old gas hoses that came with the torch are not even that old, but have considerable wear and tear and look very brittle. The old feet of the welding card are not suited to hold modern gas cylinders. They can easily slip off. Let's start by modifying the card then. Instead of having the cylinders simply be held by the feet of the card that also act like hooks grabbing into the concave bottom of the cylinders, I want to install a steel plate for the cylinders to stand on and then add additional guards that will act like railings holding the cylinders firmly in place. An old steel plate is cut in half with an angle grinder that we retrieved from the scrapyard in an earlier episode. And this is how the plate will be installed. After grinding off the sharp edges, some of the paint near the bottom of the card is removed. Now a magnetic angle is used to fix the plate in its spot at a 90-degree angle. And now I weld the plate to the frame of our oxyacetylene welding card by means of tungsten inert gas welding. With the cylinders temporarily in place, I use a pen to draw the outlines on the plate. Old flat steel is cut with this angle grinder stand, a good investment for less than 20 euros. Since the steel was coated with transparent paint in a former application, some of the surface is ground off before the steel is bent into round shapes using the old blacksmith vise. And now these bent railings are TIG welded in place. After also rounding off the edges of that bottom plate, at least the card and the cylinders are ready to go. But what about the torch itself? The first thing that I wanted to take care of were those O-rings with a dry rot on them. At first I had little faith that I would ever find the right replacement parts. But as luck would have it, the old manufacturer of the torch still exists under the name Mechanische Werkstätten Wurzen, Mechanical Workshop Wurzen in Benewitz, Saxony, is still in business and they still build the same stuff, and I bought an O-ring replacement kit for just a few euros directly from them. If it only would always work like that with 40-year-old equipment. Next I replaced the old brittle hose with a new 15-meter long hose made by the Swiss company Semperit. At this point I realized that there was little point in saving a few bucks when your life is on the line. Now that the 3 known problems had been taken care of, I went outside, put everything together and was preparing for a gas leakage test before considering to actually use the torch. I do that by spraying all connections with soapy water and opening the gas valves, looking for bubbles being blown up by escaping gases. Note that I only ever open one of the 2 cylinders at a time here. The regulators, one-way valves and hose connections appear to hold tight. But here the oxygen valve in the handpiece has a clear leak. And now I have shut off the oxygen, opening the acetylene cylinder and regulator, showing that acetylene is also pressed through the handpiece and through the oxygen knob to the outside. This is a big no-go. So I called MWW, and to my surprise they told me that they still repair and even still manufacture these very torches, and they asked me to send the handpiece in to see if it could be repaired. So that's what I did. I want to recommend them for that, as this is such a rarity in our day and age. Unfortunately, a few days later they told me that it could indeed not be repaired. So I decided to order a new handpiece for only around 55 euros. After testing for leaks and replacing many critical components, I now feel safe enough to use the torch. But I would ask you guys out there to go rather for a new one if you're thinking about that. The old gas hoses, though probably not safe enough for flammable gases, are still good enough for non-critical pneumatic stuff here in my shop. So I convert them to pressured air extension hoses. With the oxy-fuel torch ready for action, let's take care of the old laundry iron. Before further treatment, the entire iron is cleaned inside the ultrasonic cleaner. The iron is also disassembled as far as possible. The parts that I will brace are wire-wheeled to remove the thick layer of rust that has built up on this part that may well be over 100 years old. The bench grinder is used in order to grind down the edges of the crack at an angle in order to make room for the brass filler. They need to be bare iron and as clean as possible. Now the parts are placed inside this oven for preheating of the workpieces. This is a combined microwave and convection oven. And of course I do not use the microwave function for this, but this oven can only heat the pieces up to around 250 degrees Celsius. It would be better to have an oven that is capable of way more than that, but at the moment this is just all I have. In the meantime, the lower section of the iron has been submerged in citric acid as a rust removal method, as I can't reach the inside of the flat iron by mechanical means. After a few hours, the citric acid has turned into a deep yellow. The substance responsible for that is called iron citrato complex. Now the iron parts have been heated to 250 degrees Celsius. The oxy torch is fired up and I use it to further heat up the iron. I try to distribute the heat as evenly as I can, and I'm really trying to be patient here. Now the brazing process begins, as the brass is melted, connecting with the ground-off cast iron edges. I brace the workpiece from both sides. After that, I let the part rest inside the welding blanket to let it cool down slowly. After an hour or so, the part is cooled down to room temperature. A welding hammer is used to remove the slag left behind by the flux from inside the brass rods. We can only inspect the brace after it has been cleaned, but we can already see that I applied a little too much filler on the top side of the crack. But hey, I have succeeded in creating a strong bond between the parts. Otherwise, the connection wouldn't withstand the hammer blows. After cleaning, we can also inspect the bottom side of the crack. I'm okay with the midsection. Applied too much material on the left-hand side. And here on the right-hand side, I failed to create a proper connection between iron and brass. I will try to rework this at a later time. But hey, it has been my first attempt at brazing cast iron, so I'd call this at least a partial success. Let's have a look at that car radio we found then. And when I saw this is a Becker radio, I knew right away that it might be valuable. It's a Becker Indianapolis BE 7950 with an integrated GPS navigation system. Now I wouldn't repair just any old car radio, but these radios were built for Mercedes-Benz and Porsche, as far as I know, and a working unit in good condition is actually worth a pretty penny. Now these are sold listings, meaning that someone actually paid that much for the radio. It's an extreme case though, but you might get 150 or 200 bucks quite easily for one of these units. Just so you understand,
I don't go to the scrapyards to find stuff to sell, but rather to repair in these videos and use in my shop. But when I see something very valuable that I can buy for next to nothing, of course I do that as well. In order to test the radio, I connected to my car radio tester that I built a few years ago. I showed how I built the tester in a video, and you can find that in the video description below. The tester supplies the radio with 12 volts on various pins that can be individually activated or deactivated, and it also connects the amplifier to an internal or external test loudspeakers. The radio turns on, that's a good sign, but it asks for a security code. Now, just a few years ago I thought that that was a real problem, but whether you like it or not, you can buy these codes on eBay for just a few bucks. The people who sell them have a special software that can generate the codes from the serial number of your radio. In other words, I hate to break it to you, but the security code offers almost no protection anymore. The radio does accept the CD and starts playing, but it is almost impossible to select the right track because the selector knob jumps in steps of 2, does nothing, or sometimes even goes backwards. There clearly is an issue with the rotary encoder inside, and my money is on a simple contact issue. So let's take it apart and see if we can simply clean the contacts on that thing. After removing a few screws, I can just take out the entire front panel unit. It holds the display, the buttons, and 2 small PCBs with the 2 encoders. This transparent piece of plastic that is optically connected to 2 small LEDs on the PCBs first has to be removed. This spring mechanism also needs to be loosened. Now the little board can be detached from this module. After pulling off that transparent plastic part, I start to desolder the encoder. Normally I would do this with a desoldering pump, but I'm performing this repair job on my desk in my apartment, where I sometimes work in the cold time of the year. Here I only have very limited equipment, so I use a small screwdriver to pry off the component while applying heat to its legs. This is a little tedious, but I was able to remove the encoder. I now use the small screwdriver to open its enclosure and inspect the metal surfaces inside. Can you see all the little grooves on here? This is just a sign of wear and tear. And I proceed to clean the surfaces, and I also scrape them off very carefully with my little screwdriver. This is what they look like after doing that. Now, this is not the best way of doing this, but I simply didn't have anything else at hand. A replacement encoder would be better, but it can be very hard to find an exact fit for a part like this. The encoder is carefully put back together and soldered back on the board, and the radio is reassembled. So, as you can see, I can clearly select every individual track. I can go forward as well as backwards, from 1 to 10, from 10 back to 1. But I can't really play any songs here, I'm sorry. That's just because of copyright issues that I would get with YouTube.
Let's take care of the next patient then. This brushed DC motor that was used in a treadmill, in German called Laufband, is not a common find here in Germany. But as I hear, this is a part that a lot of people over in the States have used for do-it-yourself projects like electric go-karts. And this would be the biggest, most powerful type of permanent magnet DC motor that you can salvage from any piece of common consumer equipment, not counting universal motors that also could run on DC. And at 9.5 amps at 180 volts DC, it sure has a lot of power and is probably powerful enough to move a small electric vehicle. What I'm doing now is to remove all external parts that are connected to the motor shaft, like that broken fan. A screw at one end of the shaft and little worm screws here on the outside hold the pulley in place. It's for a ripped belt, similar to what is used in German washing machines. The key is pulled out of the keyway and the broken fan is removed. If the motor should overheat in a future application, I will just put an external fan next to it. On the other end of the motor we find a cast iron flywheel, in German called Schwungmasse. It increases the motor shaft's moment of inertia. I also inspect the motor brushes, and there is still enough material on there for some time to go. But I also see that one of the springs had come loose. Could this be the reason why the motor was thrown away? Now, that would be silly, but I'm sure this kind of thing happens often enough. In order to see if the motor works in principle, I connect a 12-volt lead-acid battery and it spins up. First lesson for those of you who maybe have not yet done so much with electric motors: a DC motor will work with much lower voltages than what it is rated for. But its rotational speed and power output will also be much lower. Well, but how can we test the motor at the rated voltage? 180 volts DC must seem like a very odd number. Well, here's one way. Remember the isolation transformer we built in an earlier episode of this series? If not, you can find a link in the video description. It converts the 230 volts AC of the German power grid to roughly 120 volt AC with the option to adjust it down to nearly 0 volts. And I built this to test American equipment. Since it's a DC motor, we also need a rectifier though. That's why I quickly built this high voltage, high current bridge rectifier board with an additional protection diode on it. We can connect it to the output of the isolation transformer to power the DC motor. And let's measure the voltage with the DMM. As you can see, we can spin the motor up and increase the voltage to around 120 volts DC, and that is probably what most people expected. But why 180 volts DC? And how can we get there? Well, I have now added an additional capacitor bank to the output side of the rectifier, and let's repeat the test. This time we get voltages between 160 and 170 volts DC. So here is lesson number 2. If you rectify the sinusoidal alternating line voltage and charge the rectifier output voltage to a capacitor, the output voltage will be the RMS value of the AC times the square root of 2, which in this case brings us close to 180 volts. The capacitor is not charged to the RMS value, but to the peak voltage of the sinusoidal AC, which ideally is the RMS value times the square root of 2. And I would guess that that's the reason why they chose this voltage. And judging by the nameplate, I can tell that this was definitely not built for the German market. And I think, judging by the units and so on, that this was built in America or for American markets. And that would make sense because you guys over there have the lower line voltage of 110 or 120 volts. So when you rectify 120 volts AC line voltage, as simulated here by the isolation transformer, you will get around 165 volts DC across your capacitor. I'm now developing various sophisticated motor controllers for this motor, as I demonstrate here. Five seconds, going up. 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 Down. Down, and so on. How the circuits work will be shown in a future episode about do-it-yourself motor speed controllers that I have been working on for the past weeks. On a different note, I would like to ask you for a like if you want to see more Scrapyard Repair-A-Thons and give me the clear signal to go full steam ahead with more episodes like this. If you want to support the production of new episodes actively, visit my Patreon page and consider becoming a supporter. See you soon.